Welcome to September 20th LeetCode Challenge. Find winner on a tic-tac-toe game. A tic-tac-toe is played by two players, A and B, on a 3x3 grid. Here are the rules of tic-tac-toe. Players take turns placing a character in empty squares blank, an empty string. First player A always places X character, while second player character always places a 0 character or O character. X's and O characters are always placed in empty squares and never filled ones. The game ends when there are three of the same non-empty character filling the rows, columns, or diagonal. Um, the game also ends if all squares are non-empty. No more moves can be made if the game is over. Given an array moves where each element in another array of size 2 corresponding to the rows and columns of the grid where they mark their respective characters in the order that which A and B play. Return the winner of the game if it exists, A or B. In cases where the game ends in a draw, return draw. If there are still movements to play during the game to return pending. You can assume that all moves are valid. It follows the rules of tic-tac-toe. The grid initially is empty and A will play first. Okay, so it's pretty much given index 0, 1, 2. We have 3 moves there, so we're given basically a array of moves considered of row and columns, right? So here we have 0, 0, which is row 0, column 0, right, which is the first index. And then we just basically where A goes first, then B, then A, and then B, then it keeps on going. So I'm pretty sure tic-tac-toe is a well common known game, but for instance, if we go A, so basically if A goes first, then at the end of this we always get a diagonal down here, the top left to the bottom right diagonal where A wins, because AX goes first. And then we're given the same thing here. This time we have the top right to bottom left diagonal of zeros or O's, so B wins. And then if the entire board is full, it's a draw, but then nobody wins or gets a whole 3 lines in a row. And if the game is not finished, or there's no determined winner and it's not full, then it returns pending. No repeated moves. Moves are tic-tac-toe, full rules. Straightforward. A or B wins. Check or not. Row and columns, diagonals are the same. No one wins. Return if and only if the board is full. Alright, otherwise pending. So this is located as easy, but I think it's pretty difficult. I mean, you gotta be able to program a lot to know kind of how to manipulate rows and columns pretty easily. But let's define a couple of things. So the first thing we want to know is the let's see. We know that the rows and columns of a tic-tac-toe table is 3, so call n equals 3. Let's define the rows of column. I'm going to define an array. So let's say we define rows and columns to be an array of zeros times the size n, and columns are the same thing, array of zeros of the size n. Then we want, let's see, so let row at column R, well, I'm gonna say actually, so there's a couple things, so we want diagonals, and there's something called anti-diagonals, so basically these are every single character that is not on the diagonal, so this would be the north, south, east, and left direction. So these are called them anti-diagonals or anti, and they're equal to 0. Equal 0 for now. All right, so let's allocate. Let's assign player 1 to be player to be 1. So for each row and column inside in moves, what we're gonna do is so the first move is rows is incremented is done by the player. So we add 1 to player increment 1, columns. What am I doing? Rows at location R, C, player. So let row at R and column at C be the total score. For instance, row R is going to be the total score after player A and player B have played a cell in the row R. So every time a row is being filled up with a character by a player, then it's going to represent the score of that player. Likewise, like column at C represent the score of a player, and player A and player B is placed on the cell after the column has been filled with C, right? And that's incremented by the player. So that's that. So if the row equals the column, no, row plus column I should say, equals to the length times minus 1, then we are going to update the ante by incrementing a player. And I'm going to do the same thing if the row plus column equals no, I'm right here. I need to delete this. Now this one. So if the row equals the columns, then the diagonal is going to be the score, the total score of a player A and player B after it's been placed on the main diagonal cell. Likewise, if the row plus column is equal to n minus 1, which is going to be 2, right? And then we know that the total score after a player A and B has been placed on the anti-diagonal cell. Then we increment that with player. Alright, so far so good. Next thing I'm going to do is another if statement here to look for one basically where player A has a score of 1 and player B has a score of -1. So if that's the case, then we treat that as an absolute value of rows at R if that's equal to n, or columns at C is equal to n, or absolute of the diagonal is equal to n, or absolute value of the anti-diagonal is equal to n. So when any of these scores are equal to 3, then we want to return the string A wins if the player has a positive is 1, basically, else B. So if player has a value of 1, as allocated right here in the beginning, because everything we're doing so far is giving points to player 1 as the winner, which would be A. So if the absolute values of the rows or columns or diagonal or anti-diagonal is equal to 3, then player A wins if the player value is equal to 1. Else it's going to be player B who wins. But at the end of all this, we want to do a for loop, right? Every time we go through this, we add 1 score. So this is one loop of this is for player A. And if that's true, then A is still player 1, then A wins. But at the end of all this, if we go through it the first time and nobody wins yet, then we're going to change it to player, so negative player. So it'll be -1, right? This time it's B's turn. So player is a flag, essentially. And then if we go through that and nobody wins, then we just basically go to draw, or draw if the length of moves is equal to n times n, right, is equal to 9, else pending. And that's pretty straightforward from this example here. So it's straightforward to check for A and B 1 or not. Check the row and column and diagonal if they're the same, if all three of the values are the same. That's what we kind of did. If no one wins the game, if only if the board is full, which is here, right? If 9 by 9 moves, length of moves is equal to all the 9's now, so all the is equal to 9. Otherwise, it's pending. All right, let's see what we got here. Submit. Yeah, this is way longer than easy. But at the end of this, we have time complexity big O of n, where n is the length of the moves, right here, the size of the length of the moves. Space complexity is big O of n, where n is the size 3, right here. Alright, that's it. Have a great day, guys.